Hello, welcome to my lecture on statistics. We're going to be starting with the first lesson, which is going to be all about data, definitions, and collection methods. So the first thing I want to talk about is what is data. So let's just write down X like this. This is going to be a column vector, but we don't need to worry about that. X is going to represent a set of data. So let's set this equal to some numbers, 1, 2, 3. This is my set of data. In statistics, we have two different branches. We have inferential and descriptive. So first we'll talk about descriptive statistics. I'm going to be talking about what describes X, my set of data. I can talk about things like the variance, I can talk about things like the averages, I can talk about things like the minimum, the maximum, the middle, which would be the average. But in descriptive statistics, I'm talking about all of X. I can also talk about X as if it represents a larger population. Let's say my entire population is equal to Y, which has 0, 1, 2, 3, 4, and 5. This could be my entire population, and X could be a sample of Y. So these are our definitions that we really need to focus on for understanding statistics, is that how close is the midpoint of X, or the average of X, to the average of Y, since X is a sample of Y. Now, X might not be a random sample of Y, but it's still a sample. Now, because X and Y have differences between individuals within the set, so if I pick a different color real quick, and I grab and I highlight the number 1, which is there and there, 1 is in both X and 1 is in Y. So 1 is an individual of both X and Y. And because 1 isn't the only individual in X, X has variations. So X could be considered a variable because the individuals of X vary. So one thing you might notice is that X and Y are both discrete because they have discrete values. I'm not saying like Z, oops, let me grab a different color here and let's go back to white. Let's say I have Z is equal to the interval of 0 to 1. This is a continuous variable because I can't discretely call out the elements of Z, right? The same way. So for every 2 points in Z, there's another point in between those points. And I cannot list out all of the points in Z. So it is a continuous variable. And I'm also not denoting it as a vector, I'm denoting it as a set. So we've got discrete variables like X and Y, continuous variables like Z, and I've also got, we'll do one more, I'll call it P, and we'll say this is equal to the discrete set of 0 and 1. P here can be considered a qualitative variable and not a quantitative variable. So X and Y represent quantities, as does Z, but P represents a quality, as in a 0 for a no and a 1 for a yes. These properties are very important because they completely change the methodology we go about calculating statistical inference and probabilities. So one thing to really understand about what we've covered here is that these are the definitions and the premise of what we're going to do for the rest of the course. We haven't yet talked about how to obtain X representing Y, which we will do next.